Hello friends, in the intersection of solids, today we are going to discuss a problem with two types of solids. The first solid is a square prism and second one is a cylinder. Now what are the positions of these two solids? Okay, so first solid, that is, it is a square prism. It is standing vertically with its edges equally inclined to VP. See, I am defining the correct position of first type of solid. The name of solid is a square pyramid. Square prism. So this square prism is standing vertically with edges of base equally inclined to VP. So when a square prism is resting vertically with its edges of base equally inclined to VP, clearly in the top view we observe this solid in the form of a square. So this is nothing but ABCD is nothing but the edges of that square prism which are equally inclined to VP. That means if I refer to this edge A to D, see here purposely I have marked that it's making an angle of 45 degrees. Similarly, another adjacent edge, that is nothing but CD, it is making an angle of 45 degree to VP. That means edges of base are equally inclined to VP and axis is vertical because it is standing vertically. Okay, so this was the clear-cut definition of first type of solid position. The second type of solid, here it is nothing but it is a cylinder. Okay, so this particular cylinder is penetrated through the square prism. Then what is the axis position of this cylinder? So the axis position of this cylinder is parallel to HP. Obviously, when cylinder is penetrated into the square prism with its axis parallel to HP, means in the side view, if you refer to this position of the cylinder will be visible in the form of a circle. So this circle clear cut shows you the position of the cylinder in the side. Okay. So this circle gets penetrated or this cylinder gets penetrated into this square prism. So purposely I have shown these yellow lines to represent the outline of a square prism and this somewhat red color chart I have used for showing the representation of cylinder in the side. Now what are the dimensions of these two objects? Okay, so first object, that is square prism, is having side equal to 14. Means all of the sides are equal to 14. Needless to explain. AB is also 14, BC is 14, CD is 14, DA is also 14. So this is the side of this square prism. And what is its height? So its height is somewhere mentioned in the front. So height of square prism is equal to 75 mm. So these are the two dimensions. Side is 40 mm and height is 75 mm. These two dimensions belongs to the square prism. And the second type of solid, that is cylinder, it's having diameter equal to 40 mm. It has been mentioned in the side. Diameter is equal to 40 mm. And the next point is what is the length of that cylinder. So length of that cylinder is being mentioned over here. So this is nothing but the limiting edges of this cylinder. So this length is 75. So diameter 40 and length of cylinder is 75. These are the two dimensions which belongs to the second type of solid, that is the cylinder. Okay. Now this is the side view of the square prism. This is the side. In the side view, this edge belongs to the edge A to A dash or C to C. So here I have not mentioned this A dash C dash because lot of numbering comes over the figure. So that's why just you can understand. If A means one more edge, A end point of that edge is there, that is A dash. C is equal to C dash. Okay. So this outline along with these two short lines refers to the representation of square prism in the side view, and this whole circle which is being divided into equal number of parts, that refers to the cylinder. So this is the side view of that cylinder. Now with this side view I need to plot this top view. What I have to do? I have to draw the projections backwards. So from this D to say D dash. So this projector I have considered and I have drawn this line. Somewhere here I may get this D. Likewise, this B also projected backwards. Here I may get this point B. Then A and C I have projected it backwards. I may get A over here and C over here. Okay. That means this is the representation of your square prism in the form of top view. Okay. Similarly, this circular portion, that is the representation of cylinder in the side view. This circle is divided into equal number of parts. I have divided it into 8 number of parts. You can divide it into 12 also, no doubt. So I have projected these points 1 and 5 again backwards. I may get over here this 1 and point. So see, this is 1 and this end point is 1 dash. Like this 5 is here, 5 to 5 dash also might be presented here. Then 2, from 2 to 4 I may get a single line, then I have projected it backwards. Likewise here 2 to 4 and here I may get 2 dash 4 dash. Then 3, so 3's projection is been taken backwards into this top view. Here 3 and here somewhere I may get 3 dash. So likewise 6 and 8 I have projected it backwards. Here I may get 6 and 8. Here 6 dash 8 dash. 7 if I project it backwards, I may get over here 7 and 7. So this way you can complete the top view, okay, by taking the projection backwards from the side. So once top view has been completed, you can go to the front view. Just you draw the projectors which are vertically up in direction. And to these projectors, you can take a horizontal locus from the side view. Wherever the intersection of projector drawn upwards from top view and the locus which is being taken from side view will intersect, that intersecting point will represent the view of the square prism in the front view and the view of the cylinder in the front view. So see, with this procedure of taking projectors upward from top view and taking the horizontal locus reference from the side view, so you can refer to this scale. So this portion clearly denotes the representation of this square prism in the front view, because observer is looking this object in this direction. When you observe this, he is well in position to observe A to A dash edge, B to B dash edge and C to C dash edge. So A to A dash is visible here, B to B dash is visible, C to C dash is visible. Only D to D dash is not visible. But what happens as this is being situated with its base which is equally inclined to VP? That means exactly D comes at the backward point of this B. So that means D to D dash is not visible, but it is been covered by B to B dash. So this way you can complete the projection of this square prism in the front. And for cylinder, you know the length will be visible. So length is 75. And what is this? This is nothing but the diameter, or you may say that this is the height. So you can take the reference from 1 and 5 and just you can enclose it in the form of a rectangle. So this is the representation of cylinder in the front view. In the similar way, these divisional parts, A to 8 you can transfer here. Remember, I will tell you again. This is 1, then this is 1 dash, this is 2, then this is 2 dash, this is 8, then here might be 8 dash. Like this 3 7, 3 dash 7 dash, 4 6, 4 dash 6 dash, 5 there and 5 dash. So this way you can represent the front view of the cylinder. Okay. Now I think the correct representation of these two intersected solids is more clear to you in the front view also, in the top view also, and in the side view also. Now we need to identify the intersecting surfaces points, and by identifying these points into the side view, you have to follow the same procedure. That means you need to transfer all over the intersecting surfaces points into this top view, complete the top view, and then project all the points from top view into the front view. Then you can complete the figure. Okay. So likewise, you will try to find out it here. So this is point number 1. So this point number 1 is on this edge A to A dash and C to C dash. Okay. So you can take the reference of this point number 1 here. So this is lying on this. So here I may get this as a point P1, and also 5 is also there. So this is my point P5. So P1, P5 I will get exactly at this, because this is the edge, vertical edge of this square prism, that is A to A dash. Okay. So 1, 5 I have located. Then 2 to 3, take this reference, sorry, 2 and 4, take this reference. It will come over here on this A. Okay. So this is the point where you can give this as a point P2, and one more point is there, P4. Okay. Next, this 3 you have to transfer it to the backward position in the top view. Here you may get this as a point P3. Okay. Now this 8 and 6 you need to transfer over here. Wherever those intersects to this point. This is the point P6 and point P8. Okay. Last is 7 remaining. So 7 comes from here. So this is nothing but point number P7. Okay. See, we are representing the points, intersecting surfaces point from P1 to P8 to the either side of this square prism. But remember that another intersecting points are also there, which are at the back side of this. So those we also need to plot. So if this is point P1, P7, then this must have to be Q7. Like this P6, P8, if it appears on this AD, so here on CD it will take this position Q6 and one more point, that is Q8. Okay, P1, P5, if it is on A, then this is Q1, Q5. Similarly, P2, P4 is on AB, then here Q2, sorry, here this is point Q2 and Q4. Okay, last is P3 on this edge. Here it is a representation of P3. So likewise, in the same way, you have obtained P2, P1 to P8. You have to copy those points to the remaining portion, because this is a symmetrical object. One cutting points you will get on the front side of this object also, as well as on the back side. So all our points are being located over here. Remember, these are the intersecting surfaces point. Now we need to transfer all over these points into the front. Okay. So P1, so this P1 vertically up projector, and one transferred from horizontal. So here you are going to get the point as a P1. Similarly, on this vertical projector P5 is there, you are going to get the P5 over here. Okay. Likewise, you can transfer this also. P7 you can transfer, P6, P8 you can transfer, P2, P4 also you can transfer. Okay. So in the similar way, so with the same method or similarly, as we have transferred this P1, P2, and we have obtained the points P1 and P5 in the front view by getting the intersecting point, which is obtained by projectors from top view, which are moving upwards and transferring the horizontal locus in the side view. So similarly, P2, P4, P6, P8, these points, if those are being transferred into the front view, see, P6, 8, 6 and P2 and P4. So P2, so here you may get this as a point P2, sorry, P2 you are obtaining here. Then P4 on the same line, here you are going to get as a point number P4. Then P6, P8. So here you are going to get this point as a P8, and here you are going to get this point as a P6. Okay, now P3, P7 you need to project upwards. P3 and P7. So 7 is here. So you are going to get this as a point number 7. And P3 is also here. So P3 is also here. P3, P7. Next is this point Q7 and Q3. Q7, Q3, you are going to get over here. This is Q3 and Q7. Then see, Q6, Q8 and Q2 and Q4. Both will go with a single line vertically up. Yes. So here 8 and 2. That means Q2, Q8 you are going to get. And Q6 is being remained. So Q4 and Q6 you are going to get here. Q4 and Q6 you are going to get over here. Then this is Q1 and Q5. So here you may get point Q1 and here you may get point Q5. Likewise, all over the points are being transferred from top view and transferred from horizontal view. This way you can obtain this reference. See, now you got this P1. Now observer is observing this object in this direction. Now you need to apply the concept of visibility. Okay. When a person observes this from object from this side, 1, 2, 3, 4, 5, obviously will be visible. So P1 will be visible. So 1 to 2. From this 1 to 2 you have to join. So I may join this 1 to 2. Then 2 to 3 is also visible. So this is 2 to 3. 3 to 4 is visible. 3 to 4 is visible. And 4 to 5 is visible. That is clear cut visible to you. Okay. Now, for this, again, in the same way in which we have joined, see, up to 5 you have joined, no? It is visible. What will be case for 6, 7, 8 and 1? Those are visible or not? Those are not visible. But what happens? Those lie exactly behind this point. So that means those are being covered by the continuous. Here also the same case happens. Because the object is symmetrical with this axis. Whatever the curve, nature of curve which we have obtained to this side, same is going to repeat over here. So from Q1 to Q2 it will join, Q2 to Q3 it will join, Q3 to Q4, Q4 to Q5. So it will take the shape in this way. Okay. So now this is the view in which we have applied the visibility, but just we have joined it with the help of thin lines. Now visible portion you can draw it with which kind of lines? Thick lines. Okay. So I need to transfer this continuously. So this is going to be continuous. Next, this also is going to be appear in the form of a continuous. Okay. What happens to this inside? This is a penetrated portion of the cylinder. So that is not visible. So this will appear obviously in the form of a dotted line. Okay. So next is this. This will form the correct representation. Now, in the top view, this portion obviously it will be covered, so it is not visible, so it will appear in the form of a dotted. So this is the representation of the cylinder in the top. Okay, clear? Thank you.